Okay, so the first thing I want to talk about tonight with all of you is I'm going to do a lot of stuff on triangles. Now, triangles, in my opinion, is one of the meatier parts of geometry, simply because there's a lot of different things going on with triangles. There's different types of triangles. They test you on angles in triangles. Triangles can be inscribed in other shapes, and then, of course, you have the different types of right triangles. So the first thing I want to do with everyone is I want to talk a little bit about how angles and sides interact within a given triangle. And we can draw a few different triangles out. One of the first ones that we can simply start with would be, one that people are pretty familiar with, like the isosceles triangle. Now, the isosceles triangle, and keep in mind none of my drawings are going to be to scale, is a triangle that has two equal sides. So if we're calling this isosceles triangle ABC, and we want to make these two sides the same, well, what that means is that means that angle A here and angle C here have to be the same angle. So for instance, we can make them any degree measurement we want. We could say this is 50 degrees and this is 50 degrees, and then that would leave a grand total of 80 degrees for angle B. Now, what's interesting is you have two equal angles of 50 and 50, and you can see their corresponding sides are equal. What's also interesting that goes beyond this, but it's kind of in the same light, is that the largest angle in a given triangle is always opposite the largest side. The smallest side is opposite the smallest angle. So an example of that, and we're going to kind of get into this in a second, is let's say we have a triangle like this. And obviously this is a triangle we don't see too much of, but you can see this angle here is clearly the biggest angle in the triangle. We'll call this angle C. And you'll notice that angle C corresponds with what we could easily see as the largest side. Now, the GMAT expects you to know this. Thus, they will test you on it. So the first thing I want to do tonight is I want to give a question that's testing on that idea. And then we're going to continue forward and do some stuff on, different problems where simplifying triangles is tested. So let me get the first problem up, and then we can go from there. Okay, for the sake of this problem, we're just going to have the Roman numerals up, and I'm posting it right now. Okay, so like always, everyone, I'm going to give you about 2 minutes, and keep in mind, any of these Roman numerals can be answer choices, and then we will go from there and talk about it. So I'll give everyone 2 minutes. And as you get your answer, as always, you can put your answer in the public chat so everyone can see, what different people are getting. Okay, so that was about 2 minutes. And, one of the things I bring up a lot, and I know Scott does too, is that a lot of times in GMAT problems, regardless of topic really, you're going to always see small pieces of information. And sometimes it's easy to ignore that information. For instance, in a problem like this where it says in triangle ABC, X is less than Y, which is less than Z. It's possible that you could look at that and completely glance over it, but the problem is that that's actually a really critical component of this problem. And if you don't actually read that and internalize it, you may not know where to go from here. So what's so important about this is that this is actually giving us the relative size of each individual angle. So what we know is that X is actually the smallest angle, so I'll put a little S next to it. Y is, we'll call it the middle angle as far as size is concerned, so I'll put an M, and Z is the largest angle. Now, as everyone recalls from what I just said, angles and opposite sides correspond. So that would mean that side AC is going to be the largest side, so we'll write it up here. That means that side BC, which is opposite angle X, or the small angle, is going to be the smallest side. So what is the mid-range side? Well, that's obviously AB, and that's obviously what we're being asked about indirectly, because it's not saying what is AB, it's saying which are possible perimeters. Well, the reality is we know that AC plus BC is a grand total of 16. So if we subtract from each Roman numeral, we can get relative or individual sides for AB. So if the perimeter is 22, that makes AB 6. If the perimeter is 24, that makes AB 8. And if the perimeter is 26, that makes AB 10. Now, according to what I taught everyone, AB must be between 6 and 10. So right away, you can see that you can get rid of the 6 and you can get rid of the 10. So the only possible option here is Roman numeral 2 for the side of AB. Or in other words, the only possible perimeter here is 24. So this is kind of a good warm-up question that's getting everyone into the idea that in triangles, sides and angles have a lot to do with each other, so we have to be very careful there. Now, I'm going to kind of step it up a level for the next question, because in the next question, we're going to learn a lot about not only how sides and angles correspond, but also, or furthermore, how the GMAT will give you a few angles and triangles and expect you to simplify them prior to answering a question. So what I want to do here is get this posted, and I will give everyone, again, 2 minutes to get through this. And keep in mind, everyone, this is data sufficiency, but as always, we don't have the answer choice listed, and you may have to scroll down just a touch to see the two statements. Okay, so that was a little bit over 2 minutes actually, but this is a pretty intense question, so I wanted to give everyone enough time to fully be able to try it out. And you know, this is one of my favorite geometry questions, you know, that we have, and I really like it because it's testing a lot of things that I feel are common in high-level triangle questions on the GMAT. And the reason I say that is because the only way you're going to be successful on a problem like this is if you immediately start simplifying. You know, if you take this diagram and you just leave it as is, then, you know, you're probably not going to get too far in this question. And in fact, this is going to be a very annoying question for you. But if you can kind of have that keen eye in geometry, especially in triangles, to see when the GMAT has left the door open for you to put in some extra work, life is going to get a lot better, even on what I consider high-level questions like this. So, you know, immediately upon seeing this question, the first thing that my eyes lay on is the fact that I have a 4n angle here and a 4n angle here. Now, based on what I just discussed, that means we're dealing with an isosceles triangle, so we can kind of denote that YZ, or excuse me, WY is equal to YZ. Now, there's more than just that. The other thing is that we can start simplifying angles. Now, remember, there is a grand total of 180 degrees in any triangle. So if we look at triangle WYZ, let's say we want to simplify what I'll call angle W. Well, that's simply 180, which is the total degree measurement of a triangle, minus the sum of the other two angles, which is 8n. And then we can't forget about this angle here, which we can call XYW. Because it's on the same plane with the 4n, we know any straight line has a total degree measurement of 180, and thus we get to say that this is 180 minus 4n. Now, to be clear, this is the stuff you want to be looking for in a question where they're providing angles and they're leaving space open for you to simplify. Of course, the question that we're dealing with is side XY greater than side WZ, so we want to keep that in mind. Now, what statement 1 tells us, and it just scroll down a little bit and you'll see it, is that angle WXY, and I'll just write it at the top, equals 2n. Now, again, we want to first plug that in, and you know, one other thing to mention is if you are on an actual GMAT, now obviously I have the screen here, I can write next to my shape. This is definitely something you're going to want to sketch out. So you're never going to want to just look at the information on your computer screen and then extract it onto your page, but rather you're going to want to write out this entire diagram for sure. Okay, so we see that WXY is 2n. Now, what that means for us is that we have 2 out of the 3 angles of our triangle here. So we can do the same thing we did with the larger angle W as we're going to do with the smaller version. So what we're going to say is that that's equivalent to, and I'm doing this in green, 180 minus the combined sum. And this is where you have to be really careful. And this is why I put these brackets in, because I see students make this mistake all the time. Add this together first and then subtract it. Because without those brackets, just so you can see it, you have no idea really what you're subtracting. But with the brackets, you know that first you're adding all this stuff together. So this gives you 180 minus, in brackets, negative 2n plus 180. I'm running a little bit out of room, so I'm just going to take my arrow off. And this becomes 180 minus, and remember, now you're distributing the minus sign within the brackets, so actually that makes it a plus 2n minus a 180, and after all that work, we're left with 2n here. Now, this is extremely important because we have a 2n there, which I'll highlight, and we have a 2n here. So what triangle WXY is, and keep in mind, this probably should have been said that it wasn't drawn to scale, because clearly it's not, that we have an isosceles triangle. And so what we do is we go opposite that angle, which I'll do in a different color, and we see that side xy is also equivalent to side yz. Now, if xy is equivalent to yz, then it also, to wy, then it also has to be equivalent to yz. So here's what we know. We know wy equals yz, which equals xy. And this is super, super important, because if we go down to the question, it says, is the length of xy greater than the length of side wz? Well, clearly we can say the answer to that is no, because they're equal. So that makes statement 1 sufficient. Now, statement 2 on its own is simply telling us that xy is 4 without having any other information, because remember, we know nothing about these angles. That's simply giving us one of the sides here, and that's definitely not enough information. So this leaves us with statement 2 being insufficient, and the answer here being A. So if some of you struggled with that and you thought this was a lot of steps, keep in mind this is a high-level question. You know, when you see something like this, GMAT is definitely expecting, you know, a very high level of detail from you to be able to get through this question. So the last thing I want to cover tonight is I want to talk about 2 different types of right triangles that you're expected to know in the GMAT. You know, the good news is you don't have to know any trigonometry on this test, which is nice. But a few things that stem from trig are some of the right triangles that they expect you to know and some of the side angle relationships that you're expected to know. So 2 popular ones, and I'm sure most of you know exactly what I'm getting at, is the 45, 45, 90, and the 30, 60, 90 right triangle. The beauty of this is that once you know either any 2 angles or any 2 sides, you can tell right away if you're dealing with a 45, 45, 90 or a 30, 60, 90. Now, remember, my triangles, I'm just drawing them out. I'm not trying to make them to scale. The 45, 45, 90, what we need to know is that if we're talking about the side ratios, the side opposite the 45 is x, the side opposite the 45 is x, and the hypotenuse, or the side opposite the 90, is x root 2. For the 30, 60, 90, the ratios are slightly different. We've got the 90-degree angle here, 30-degree angle here, 60 here. We have x, x root 3, and then 2x. So what we're going to do is we're going to do a couple problems that are tested on this, and then we're going to go from there, and I'll be turning this over to Scott. Okay, so I'll give everyone 2 minutes here. Okay, so this question, I think I gave everyone a little bit over 2 minutes, but this one, you know, if you are following the rules I just taught, it shouldn't be too bad. Now, one of the things I never mentioned about the 45, 45, 90 triangle, one, it's actually the same thing as half of a square. So if I were to just add a square here, there you go. That's half of a square. So these rules apply to when you hear the words diagonal of a square, which is also tested. The other thing is with this type of triangle, if you truly needed to, you could use the Pythagorean theorem. But obviously, if there's a shortcut to do something on a timed exam, it's a no-brainer. Use the shortcut. I realize that this, on top of every other thing that you're told to memorize, can get overwhelming, but, you know, that's why the flashcard was created. And I know as long as you have it there and you're able to review it from time to time, this is something you probably will not forget. So if we're going back to our side angle ratios here, we have x, we have x, we have x root 2. The first thing you're going to do is you're going to do anything possible to solve for x. Notice here, the hypotenuse is 6 meters, so you say that x root 2 equals 6. What's the purpose of that? Well, now, with that equation, which I'll write on the side, we can see that we have a value for x. Now, the next thing I'm going to do is not mandatory, but it's something that's probably going to help you because 9 times out of 10, your answer choice is not going to be left with a radical in the denominator. So what you need to do is you need to what's called rationalize that denominator. To do that, you're going to multiply by root 2 over root 2. The reason you're doing root 2 over root 2 is, first of all, you can't change the value of the expression, and root 2 over root 2 is 1. And when you multiply root 2 by root 2 on the bottom, you simply get 2. So now all of a sudden your value of x is this, and if you simplify it down, you get x to equal 3 root 2. So notice, and I'll change the color here, x is 3 root 2 here, x is 3 root 2 here, and it's a grand total of 6 here. So if we are getting well, we're only getting the area of the triangle. Good. I thought we were getting the perimeter, so I just did some extra credit for everyone. So we don't really care about 6. What we care about is the fact that area is base times height over 2. Now, for those who have been reading along our curriculum, we actually just say L squared over 2. The reason we say L squared is because our 2 legs are equal. Doesn't matter how you do it. You know, at the end of the day, it's all going to come out of in the wash, and you should end up with the same answer. So 3 root 2 squared over 2 gives us 9 times 2 over 2, which gives us an answer of 9. Of course, it would be meters squared. So hopefully for everyone here tonight, what I just showed you was more or less business as usual as far as geometry goes. And to stress once again, this is a massive chapter, but a very doable one. And for anyone who hasn't gotten to geometry yet, you know, one of the first things you want to do is you probably want to go through and you probably want to memorize formulas. And, you know, for those of you who don't know this, you know, on our new website, which is coming out very soon, we are going to be giving everyone an opportunity within their own student center to have access to all of the must-knows. Now, what's so powerful about that is if you go to a chapter like geometry, all of those must-knows will be there for you, which basically are going to contain all of the formulas you need to know, and you can get those guys memorized right away. And then if you want to, circle back and read the chapter, because the more formulas you have down, for sure, 110%, the easier all this is. So with that said, Scott, I will let you get into some more advanced stuff, and you can take it away. I'll pass you the ball right here. All right, you should be good to go. Yeah. You sound good, and the audio's good.
Okay, good. Great. Hey guys, thanks for coming tonight, and Jeff, thanks for doing the first part of the webinar. As you can tell, Jeff's pretty sick, but he did a great job. So what we're going to do, and don't start on this problem yet. As Jeff said, geometry is so varied, and we'll end up likely doing, probably 10 webinars in geometry. There's no way we cover everything tonight, but I'm going to cover a bunch of high-value stuff sort of in the next half hour as well. What I'm going to try and do is integrate in a bunch of concepts that if you've been playing around geometry questions, you've seen this stuff. If you have not been playing around geometry questions, you may not expect all of these topics to be rolled up together, but let's give it a whirl. So we'll do a little bit more difficult. So we'll do about 2.5 minutes per problem. And why don't we start in this first guy now? See how it goes. Hey guys, I just reposted this question. I think somebody for some reason didn't see it. Okay guys, so that was a little bit of extra time there. So let's go over this together. So what we have is we have a circular piece of aluminum, and we know it has a diameter of 2x meters. It has a diameter of 2x meters. So what that means is that the radius of the larger circle is just x meters, right? Because the radius is obviously half of the diameter. So what that means is that the area of the larger circle, area is equal to pi r squared. So if our radius is x, then the area is equal to pi times x squared, or the larger circle here. And then it tells us that 4 circular holes are drilled into this piece. So it doesn't really matter where they're drilled, but at some point, 4 circular holes are drilled into this circular piece of metal. And it says that each of these little circles has a diameter of 2y meters, right? So the diameter of each of these guys is equal to 2y meters, okay? So if you think about what that means, it means that the radius of each of the smaller circles is simply equal to y meters, right? Because we know that the radius is going to be half of the diameter. Okay, so far so good? So if you think about it, we're removing those 4 circular holes. And we want to know which of the following properly expresses the percent change of the area of the piece. And to do this, we have to, of course, be familiar with percent change. And it's a really simple equation, the percent change. And of course, the triangle means change in. So percent change is the final value minus the initial value divided by the initial value, all multiplied by 100. Okay, so if we're looking for the percent change in the area of the piece, we need to have the final area after the pink holes are drilled out and the initial area, which is just the area of the large blue circle, prior to us removing those little pink circles. Okay, so if you think about it, what's the area that we remove? Well, there are 4 circles, right? 4 little circles. And each of those guys have an area, let's say area smaller. Each of those guys have an area of pi y squared, right? Because remember, area is simply pi r squared. And we said that the radius of the smaller circles is y. So what that means is the area is pi times y squared. But if you think about it, there are 4 of them. So the area removed would simply be equal to 4 times pi y squared, right? And just to make sure everyone's following along, so if each of the smaller, that color's not going to work. So if each of the circles have an area of pi y squared, and if you have 4 of them and they're all the same, well, you're removing a total area of 4 pi y squared from the big blue circle. Okay? So then, with that information, we can calculate the percent change. So if you think about it, now watch carefully here. So the final value is the initial value of the blue circle, the initial area of the blue circle, minus the 4 pi y squared, which is the area we have removed, right, those little pink circles, minus, so here's the initial value is pi x squared, right, that's just the initial area of the blue circle, divided by the initial value of the area of the blue circle. And of course, this is multiplied by 100. You guys, of course, obviously you're going to have to scroll down to see some of this. So now we need to simplify this, and it's just going back to the stuff that we always preach, which is A, you need to capitalize on every factorable opportunity that you can. And you can notice here that in the numerator there are 3 terms, and each of these terms contains a pi. So what we can and should do is factor out that pi, and we'll be left with x squared minus 4y squared minus x squared over pi x squared. And of course, this is still multiplied by 100. And of course, the benefit to factoring out that pi was we can see that this pi will cancel with this pi. And then in the numerator, in those parentheses, we see we have x squared and minus x squared, and those guys cancel. And I'm going to have to write small over here. But we're basically left with minus 4y squared over x squared times 100, right? Which gives us minus 400y squared over x squared. And at this point, there's nothing more that we can simplify. And let's hope that that answer choice is up there. Yes, it is. So that's answer choice B, as in boy. So this is a really good problem. A, because it's pretty challenging, and B, because it integrates a lot of ideas, right? We had the area of the circle, we had to sort of logically figure out the total area removed, and then we had to integrate in the idea of percent change. And you're going to see a lot of medium to difficult GMAT problems do just this. They ask you, not just to do something with a triangle or with a circle, but they actually ask you to integrate in a lot of different parts of your knowledge. So give everybody a minute to catch up any notes on that, and we'll do another one. Okay. So keeping with our theme of integrating in different topics, what we're going to do is we're going to integrate in a rate equation with a geometry problem here. So the key to any word problem is A, take it step by step, and B, with geometry, make yourself a drawing. A picture is worth more than 1,000 words on the test. And we'll shoot for about 3 minutes to do this, guys. Let's start our clocks now. Okay, guys, that was about 3 minutes. So we have a car that leaves point A and it travels east on a straight road, and we know that it travels at a constant speed of X miles per hour. At the same time, the second car leaves point A and it travels south on a straight road at a constant speed of Y miles per hour. So let's just diagram that out. It's going to become a lot clearer. So let's say this arrow is emanating from point A and going east, and this arrow is emanating from point A and going south. Right, so this is our starting point right here. This is A. And it says that the car that leaves A travels at X miles per hour, and the car that leaves A and goes south travels at Y miles per hour, right? We have speeds of X and Y respectively. It says, which of the following equations properly expresses the distance in miles that the two cars will be apart after T hours? Well, you know, guys, here's the biggest secret about math. And if you can catch on to this, you're going to be ahead of, like, literally everyone in the world. And that's not an exaggeration. So the beauty about math is no one can lie to you. No one can deceive you. No one can trick you. And you're saying, yeah, right, that's the whole GMAT. But it's not. Right? They're only going to trick the people who haven't got the information down pat. Right? In all other disciplines, maybe with the exception of chemistry and physics, you know, things that actually rest upon mathematics, people can easily deceive other people who are unsuspecting. And I'm not saying that people don't do that in math as well, but it happens to the unsuspecting people. And where is all this going? Well, in these word problems, they have to give you the necessary facts, right? How often can you say that happens in the business world? And B, they have to actually ask you the question they want to know. And how often does that happen, right? So on a problem like this, the clues are all in the stem, right? So for example, it says which of the following equations properly expresses the distance in miles? Well, immediately we're talking about distance. Like, all we need to do is say to ourselves, well, distance is equal to the rate an object travels multiplied by the time it takes, you know, multiplied by the traveling time. And it's that simple, right? So right away, now what we can say is the distance the car that travels east travels is equal to xt, right? Because they're asking us, you know, how far will the cars be apart after t hours? Okay, so that was a critical little piece of nugget I just gave you, is that in a word problem, everything is there, and what will be asked is exactly what's needed. There's no ambiguity going on. Okay, so the distance is x times t from A to the east, and then the distance going south will be equal to y times t, right? X times t and y times t. And that's a very simple equation that obviously, you know, almost all of you knew. Distance is rate times time. Well, now they're asking you how far are the cars going to be apart. And of course, if you think about, like, the physical distance that these cars are apart, well, it's the hypotenuse of a right triangle. Big surprise, right? Okay, we know this is a triangle, a right triangle, because we let one ray emanate to the east and one ray emanate to the south, so this is by definition a right triangle. And if we let D be this unknown distance, and this is where I want you to pay careful attention, well, we can write an equation. We can say D squared, right, the hypotenuse squared, is equal to the length of one side squared plus the length of the other side squared. All right, so just remember, because distance is rate times time, we actually algebraically let the distance of this line be xt, and we let the distance of this line be yt. And if we're solving for the total distance, well, we can use the Pythagorean Theorem. Okay, so now we're just down to some exponent rules, right? So remember that those 2's belong to all of the characters inside. So we would say the distance squared is equal to x squared multiplied by t squared plus y squared multiplied by t squared. Okay. Again, take every factorable opportunity you can. You can see here that in these 2 terms, they both share the t squared variable. So immediately, without really giving it any thought, we're going to pluck that right out of there, pull that right out. So we'll say d squared is equal to t squared, and then inside of there we have x squared plus y squared. And of course we're solving for d, so we're going to take the square root of both sides. So when we do that, we have d is equal to t times the square root of x squared plus y squared. Now, before we summarize the problem, students always say, well, why did the t squared become t, but the rest of this became just what it was before, but under the radical? And the answer is that, I'll kind of do it over here to the side in pink. Well, if you think about it, what you did is you took the square root of the entire, it's going to be a little jumbled up, but you took the square root of the entire equation, and the square root of t squared is just t, and the square root of d squared is just d, right? So square root of d squared is d, square root of t squared is t. However, this, the x plus y squared, had to stay under the radical because remember, the order of operations dictates that we must resolve any calculations under the radical before we actually take the radical. Okay, so obviously, for some of you that may be a discussion for another day, but at least take note of that and be on the lookout for that. So let's see, do we have that answer choice up there? Let's scroll up. Yeah, we do. So that's answer choice A. Okay, so again, in this problem, all we did was we carefully decoded the word problem and we integrated in the distance formula. And as I said, it's important when you work in geometry questions to not be shocked if you have other topics or concepts that get woven in there. Okay, why don't you catch up with that? Take any notes you want to take down on that guy. Okay, let's do this guy. It's not that difficult, so why don't we shoot for a strict 2 minutes on this guy, starting Okay, guys, that was about 2 minutes. And yeah, definitely fill out the feedback form. As I always say, we'll try and tailor these webinars to whatever interests or deficiencies people have. And you'll let me know as you fill out that form. So please make sure you do that after the webinar. So for this problem, so we have a certain triangle and the lengths of the three sides form consecutive integers. Well, let's stop right there. So it's important to be able to algebraically express three consecutive integers, and by that I mean like 1, 2, 3, or 5, 6, 7, or 86, 87, 88. Anything where you have three numbers that are consecutive. Okay. So the way to write this algebraically, and this is important, is to say the numbers are n. We could say the next number is n plus 1, and then the next number is n plus 2. So that's how we would algebraically say three consecutive integers. You could use x, you could use b, it doesn't matter. But as long as it's n plus 1, n plus 2, that's how we algebraically write three consecutive integers. Okay, so this triangle, it says the length of its three sides form three consecutive integers. It says if the length of the triangle's shortest side is 70% less than the perimeter of the triangle, what is the length of the longest side? So if you think about it, so this triangle will definitely not be a scale, but if we have the triangle that we're dealing with, especially we could say the sides are, n. We could say the next longer side was n plus 1, and the longest side would be n plus 2. So just to remember, in a triangle, the hypotenuse has to be the longest side. So then what that means is the perimeter is simply n plus 1 plus n plus 2. So then the perimeter is 3n plus 3. Okay, algebraically, the perimeter can be represented by 3n plus 3. So what it says is the shortest side is 70% less than the perimeter. So anytime we know that something is 70% less, it's really helpful to say to ourselves, well, that means it's 30% of, right? So if you're 70% less, you're 30% of. Right? Say you save $100. If you lose 70% of that, you have 30% left. Okay, so we're going to decode this. Watch as we write the equation. So we are going to say that the triangle's shortest side, which remember by definition is n. Right? By definition, we let the shortest side be n. So the triangle's shortest side equals 30% of the perimeter of the triangle. At this point, we just have a very basic linear equation. We can, our goal would be to eliminate the fraction quickly, or you can multiply the 3/10 through. It's up to you. It depends on what you like to do. So let's put it through. So let's say this becomes 9/10, so 0.9n plus 0.9, right? 9/10. We can then bring let's see what the next easiest thing to do. Let's bring the two terms with the n together. So we'll say n minus 0.9n is equal to 0.9. Okay, so the reason why I did that is because obviously we're going to solve for n here, and so n minus 9/10 of n is 1/10 of n is equal to 0.9. So n here is equal to 9. And you didn't have to solve it the way I did. Most of the time I actually don't use decimals. Just a moment I like writing the decimals out. You could use fractions. You could have done a lot of different techniques here, whatever makes sense for you. But we see n is equal to 9. And as Jeff told you earlier, like if you're in a rush, you can bet you'll answer A. But A is not the answer. So on the test, a lot of trap answers are strategic values, meaning, they're not like values that are like insignificant in the problem, but they're like, okay, I just did a lot of steps and I got this answer, and then you see the answer up there. Well, you got to make sure that the answer you're picking is actually what's being asked. Okay, so we have the value of n, which is the length of the shortest side, but obviously the question asks, what's the length of the longest side? And the longest side was expressed as n plus 2, so that makes the longest side actually 11. Now, I would say 5 to 10% of wrong answers in the students I have result from doing something like that, right? So actually getting n equals 9 and picking 9 as the answer, not, kind of forgetting that what's really being asked is what's the longest side. So obviously you don't want to do all that work and then be penalized because you didn't carefully answer what the question is actually asking. Okay, so that's all for me. Jeff, I'm going to turn it back over to you with any last words of wisdom or anything else you want to mention.
Yeah, well, just thanks again for coming this week. And like Scott said, definitely fill out the feedback form so we know, your thoughts on these webinars. And as I said earlier, in the webinar, we'll give everyone an update next week. But the new site is coming, so we're very, very excited. Everyone here will be well aware of that happening, and especially those who are here from Forte, you'll be getting an announcement as well. So if anyone needs anything in the meantime, always feel free to reach out to Scott or I, and we'll be happy to answer any of your questions.
Okay. Good night, everybody.